Good afternoon. This is Chuck Ridgway. I'm the Automation Technology Manager at Horner. Welcome back to another Tuesday live stream. Today's topic is how-to on firmware updates. So joining me as usual is my friend Mr. Casey Gardner. How's it going, Casey?
Hey, how's it going, Chuck?
It's going great. And joining us in the background is Marcy Tyree. How we doing, Marcy?
I'm great, Chuck. How are you?
Excellent. Casey and Marcy will be kind of monitoring how things are going. Casey will answer any technical questions that might come up during the chat. And I'll be trying to present the material. Hopefully that's informative for you. So today's topic, Casey, firmware updates. Several reasons you might want to do a firmware update. Obviously, if there's a new feature you're interested in, what could be some other reasons?
Yeah, that would be the first and foremost. And then probably some others would be maybe along the way we come across a bug or something specific that may be fixed and represented differently in a newer version. So that'd be definitely another reason to jump up as well.
Absolutely. Another one I can think of that can affect some customers. I know in some industries there are some pretty strict requirements for qualifying a machine for not only the code that's running in the PLC or the all-in-one controller, but also the firmware has to also be maintained throughout the life of the machine, or at least it'll have to get reapproved if it doesn't have the same firmware. So some customers will actually want to downgrade to a specific version of firmware. So maybe the firmware continues to advance, but they need to stick with a certain version, so they actually need to downgrade firmware. So that would be another one as well, right?
Absolutely. And I mean, one reason to just stick on that version is kind of like you said, and sometimes where they get certified for a specific version, but a lot of times it's kind of one of those, if it's not broke, don't fix it kind of things. If you're not really having a reason to upgrade, you don't necessarily have to either.
Absolutely. If there's nothing in it for you, then why do it, right? I mean, if there's no new feature you want to take advantage of, or there's no particular bug fix that you're interested in, then there's no point to do the upgrade. Absolutely. Let's just stick with it, right? Mm-hmm. All right, very good. Okay, so let's just jump into the program here. All right, let's get started with how-to on firmware updates. So today what we're going to do is, we're going to talk a little bit, conceptually about firmware updates in terms of the methods that we use, what firmware updates actually consist of, those sorts of things, to try and give you some good information you may not have had. We're also going to do some demonstrations on doing actual firmware updates on Horner products, because there's some differences between how firmware updates are done for sure. And also, even for those of you who are Horner veterans who think that you've seen it all when it comes to firmware updates, you're going to see some new things that we're doing with firmware updates that nobody has seen outside of the building before. So we're excited to show you that as well. Okay, so just to kind of get everybody on the baseline, what is firmware? That's the code that runs on the OCS hardware. It's what provides the OCS product with its functionality and features. And remember, when we talk OCS, we're talking about the Horner Operator Control Station, which is our brand name for our all-in-one controllers. So in addition to the firmware being the code that runs on the hardware and providing with the functionality and features, it basically is going to be executing whatever the configuration and the application program are that have been loaded onto the unit, by the system designer. So you as a system designer, you configure the system the way you want it, you program the OCS to do what you need to do, and the firmware is going to execute your code. Now, one of the great things about doing business with Horner is that our Horner firmware updates are free. So, your product could be 6 days old, 6 months old, or 6 years old. We're going to support you for the life of the product. So if there's a newer firmware update that you want to change to, and you've got a Horner product, doesn't matter the age, you're going to be able to do that. Another important point to keep in mind is we really work hard to maintain forward and backwards compatibility where we can. So what does that mean? Well, if the firmware that you have is newer than the version of Cscape than you created your program with, generally that's no problem. If your version of Cscape is newer than the firmware that is in the controller that you're using, that's generally no problem either. Where it's a problem is, and not really a problem, but just something to keep an eye out for, is if you've got a newer version of Cscape that is supporting some brand new features, but the firmware you have isn't supporting it, well, you're going to have to upgrade your firmware at that point if you want to take advantage of the new features. So again, creating time machines is not our specialty. So we do several things really well. Creating time machines is definitely not one of them. So let's talk about firmware in a few more specifics, because we tend to use firmware as kind of a general purpose term. In reality, it refers to several different components that kind of act together to be the firmware. So it can be pretty confusing sometimes based on some of the terms that are used. So first of all, one major part of the firmware is the operating system. So all OCS controllers from day one, and keep in mind, we've been making all-in-one controllers since 1998. And even that product had a operating system embedded in it. Okay, so every OCS controller has an operating system. It just varies by product family as to which one it is. Secondly, what we call the firmware is the main code that's been created by Horner engineers and is maintained by Horner engineers, again, that provides that main functionality and features. And then there's an additional piece called either the FPGA or the CPLD, and that is special code that runs in specialized chips that are used for our high-speed processing, our high-speed counting, to do quadrature or to count signals that are faster than the logic scan rate. And on the output side, to create, step and direction type outputs, or very high frequency PWM or frequency type outputs. Those are handled in a special chip. And that chip needs code, and that is either an FPGA chip with FPGA code or a CPLD chip with CPLD code. And what do those stand for? FPGA stands for Field Programmable Gate Array, and CPLD stands for a Programmable Logic Device. Okay, so there's different elements that make up the firmware when we talk firmware. All right, now let's talk a little bit about the different update methods that are used by Horner controllers or Horner products in general to upgrade their firmware. The first we're going to talk about is products that utilize a serial port or a USB port to effectively update their firmware. And this also goes for legacy Horner products as well. So again, any products that are older than what you see here, like the old text-based OCS 100s or some of the original graphics units, those units almost certainly are updated over the serial port. And then the newer units that use this method, they actually have a USB port, which you should probably use because it's going to be faster than the serial interface. Now keep in mind, USB just stands for Universal Serial Bus, so it's not too surprising that you might use a USB port to update firmware. Okay, now the first thing we want to do in terms of demonstration is I want to show you a firmware update I did earlier this morning on a X4. Okay, so that's the Micro X4 is one of our products in the Micro family. And let's show, I want to show you that. But before I do that, let me show one other thing. And that is, I want to mention real quickly where you can go on the Horner website to find firmware to find firmware updates. So if you go to our homepage at hornerautomation.com, okay, and if your browser is kind of in this narrow mode, all right, maybe not full screen, then you're going to find a menu here, which is going to have several options, including support. Okay, and downloads is one of your options here, and then controller firmware is the place where you're going to find your firmware. Okay, now if your browser is in full screen mode or wider, then you'll actually have a support tab that you can click on, go to downloads, controller firmware. Okay, and that basically gets you to the controller firmware page, which has all the different versions of firmware that are available for all the products, sorted by product effectively. So I just wanted to show you that before I went ahead and showed you the firmware update that I performed this morning on the Micro X4. So let's go ahead and kick that off right now. As always, when we are updating the firmware in a controller, we need to start from the controller firmware page on our website. We're going to be updating an X4, part of the Micro series, so we need to scroll down just a little bit, expand this section. I'm interested in the latest version. Now, it's always important that we download release notes. I've done that here. Gives us all the latest enhancements, as well as any other important notes. I'll go back to the firmware page, hit download. Okay, it's downloading a zip file to my downloads directory. All right, I'll go ahead and get out of the browser here, go to the file section of my computer, go to the downloads area. There we go, X7 firmware, or I'm sorry, X4 firmware. I'm going to go ahead and drag that to my desktop, which is what I want to do here. I will extract all. It's going to extract it to a folder on my desktop. Okay, and then here we have an executable. This executable is going to, when I run it, it's going to copy the appropriate firmware files for the X4. It's going to copy that to the right directory in Cscape. So I'll go ahead and double click on that. Okay, it's, you know, as often happens, Windows is trying to protect me from myself. I do want to run this app. Okay, it's effectively going to take these files, put them in the right directory, which happens to be the firmware folder, wherever Cscape is installed. Okay, so that's complete. All right, so we now have the right files in the right location. Okay, I've got my X4 controller here. It's connected to power and USB. All right, now we fire up Cscape. Make sure we have our program backed up, okay, because we're going to lose our program as part of the firmware update. All right, and then let's go ahead and go to File, Firmware Update Wizard. We want to make sure we're communicating with the controller before we press the update wizard, and we are. It's saying we've got an X4 connected, or that is featuring the C-SCAN network. That's what the Micro series supports. And we just want to hit OK. Okay, it's giving us a little bit of a warning here. And you can see what's happening with the front of the controller. It is basically ready to load firmware. We press start, and now that process begins. Okay, the unit's rebooting, running a self-test. That's normal. Showing a configuration error. That's also normal because it doesn't have a program in it anymore. Okay, so the firmware is complete, firmware update. I'll go ahead and hit close. Update is complete. Now we need to download the program back into the controller. We've all seen program downloads before, so keep in mind, once this download is complete, we'll need to put the controller into run mode, and then we'll be done. We'll wrap up the video here. So it always helps when you play the correct video, or at least set it up or cue it up properly before the show starts. So that's the serial method that's used by not only the Micro series, but also the XLE and XLT. And one thing to keep in mind is there are plans for these products in the future to be updated from a memory card. So that's something you will see relatively soon from these products. Most of the feedback we've gotten from customers is that the method they do prefer for doing firmware updates is the next one we're going to show you, and that is doing the update from removable media. So in that scenario, you basically take a set of files, which is the firmware files, you copy those onto the root directory of a micro SD or a USB drive if the product supports USB. And when we say USB, we're talking about the full-size USB-A type ports, and not all these products have them. although most do, but not all. And then once the micro SD or the USB drive is plugged in to the unit itself, the user initiates the update from the controller itself. So that's basically what's involved with doing the update from the memory card. So now let's take a look at how I did that this morning, if I can queue up the proper video this time. Okay, I'm going to show you the process that I like to follow when I'm upgrading a unit with new firmware, especially if that unit already has a program running in it and I just want to quickly get the firmware updated and then get the machine back up and running as soon as possible. So what I have here is just a simple micro SD card. This one's a 16 gigabyte. Nothing special about it other than the fact that it's easiest if they're 32 gigabytes or smaller, because that means they're already formatted and ready to go. Okay, so I'll just go ahead and install this memory card here in the XL4 that I'm upgrading. Okay, I'm going to go to the System menu, go to the Removable Media menu here. It's showing that, yep, my card's in there, but it's empty, which is fine. That's what I was expecting. I just bought this card. I'll go back out to the main menu and go to the Clone Unit menu. All right, I'll hit Enter. And then I'm going to make a clone. So what this is going to do is it effectively is going to back up the program and all the settings and all the registers and all the variable values and everything. And it's going to create two files called autoload.pgm and clone.dat that then I can use after the firmware update to completely restore my unit to its exact status, other than the firmware, of course, after I do the upgrade. Okay, so I'm done here. So I'm going to go ahead and pull the card back out and put it in my computer next. Okay, I'm going to go ahead and pop the memory card into my computer. You can see it's come up here as drive E. All right, well, the next thing I need to do is acquire the firmware files for this update. So I'm going to go ahead and go back to the firmware download page, the controller firmware download page on our website. And I need to scroll down to find the XL4. There it is listed under XL series. Okay, and I'm just going to go ahead and select the latest version here. I can download the release notes, which is always important. I'm going to go ahead and do that now. All right, so that's telling me all the different versions or all the different individual files that make up this firmware update. I'll go back to the firmware download page here and go ahead and hit download firmware. Okay, that set of files is downloading. All right, it's now available. I'm going to go ahead and go to my file area. I'll go to my downloads directory. There's that file that was that I just downloaded, the firmware file set that happens to be in the form of a zip file. I'm going to go ahead and drag that to my desktop. That's what I like to do. All right, and then I'm going to go ahead and extract all. Okay, it's going to extract everything to a folder right on my desktop. That's what I want. Okay, and it's opened up these files that were extracted. I'm going to go ahead and select all these files, and then I'm going to right click and I'm going to send it to my memory card, which happens to be drive E. Okay, so now I've got the files on my memory card and I'm good to go. Okay, now I'm ready to take that memory card that I just ejected from my computer, put it back in the OCS. All right, let's go back to the System menu and take a look at those files that are on there. Okay, so as you can see, we've got all kinds of files from the firmware update package, along with autoload.pgm and clone.dat. Those are all there. Okay, so we're ready for the firmware update. How do we do that? Well, effectively what we're going to do is we're going to press and hold the System button for several seconds. Okay, and then the boot installer screen comes up. Now it's really important that we press Install Bootloader. All right, that's what we're doing here. We always press Install Bootloader. Are you sure? Yes. Okay, and now we wait for the firmware update to execute. So it's updating everything. It's updating the bootloader, which of course is the operating system and any other files related to the operating system, and it's upgrading the firmware, and then it's also upgrading the FPGA or CPLD, depending on which is present in that particular controller. And it's doing all that in less than a minute, really. So it's not quite complete yet. Should wrap it up any second now. Again, this is a lot faster than doing it over USB or serially, which you need to do with a product like the Micro OCS today. Okay, so the operation is complete. It's telling us to remove the media card and reset the unit, and that's what we will do. So I've removed the media card. I'm going to go ahead and reset the unit. Now, when this thing boots up again, it's going to boot up without any program in it, right? That's why we performed the clone before we did the firmware update. So we're going to get some errors, but those errors are just basically saying I don't have a valid. It's saying I don't have a valid program in it. Is really what it's saying there. Okay, so now we're going to go ahead and we're going to restore the unit back to what it was when we first performed the clone operation right before the firmware update. So I'm going to go back to the system menu, go back to removable media. Oh, it's not. I popped the media card. Remember, you got to remember to put the card back in, dummy. There we go. I'll go back out to the main menu, back to clone unit. Okay, and then this is very important. We're not going to make a clone. We're going to load the clone. That's what we want to do here, and that's the first button. So we press load clone. It says, are you sure? I am. It's loading the program. Okay, it's doing a power cycle, which is normal. Okay, it's going to load the program, do a power cycle. It's going to restore not only the program, but all the registers and variables and settings and everything else that were there. As you can see, this time all my self-tests passed, and I'm back up and running. So that's the complete process for doing a firmware update to an XL4. And this process is the same for the XL7, the EXL6, EXLW, EXL10, X5, all those products in this same family. Okay, there's a few points I want to reiterate from that last demonstration. Okay, a couple little things you may or may not have caught on. First of all, you really would only do a clone in the case of an application that's already existing. So in other words, the machine's already been running for a period of time. Everything's the way you want it exactly. In that scenario, you're going to do the clone first. That's the best thing to do, at least. If you just have a unit you just got in, that doesn't have a program in it, there's no reason to clone it, obviously. You can just go right into the firmware update that you want to do. So that's one point I want to make. Another point is when you purchase micro SD cards. Now, we sell micro SD cards that's primary advantage is they're designed for industrial applications. Not that they're any more rugged or anything, but two, that they are much harder to counterfeit. One issue with just going out and buying a micro SD card from the drugstore, which probably will work fine, okay, is that there's always the potential that you'll get a counterfeit micro SD card and you could run into some problems. So if you need to go grab a micro SD to do a quick firmware update, don't hesitate to go to the drugstore to do that. But if you're going to load one up at the factory that you're going to ship with the machine, investigate possibly sourcing those from us, not because we're trying to make money on it, but because they're just a little bit better card that doesn't have the risk of counterfeiting that some of the name brands do. Okay, a couple of the things I want to point out. One is some of you may be thinking, well, geez, all you had to do to initiate a firmware update was press and hold that system key. I'm worried that some of my operators might start playing around with keys and do that. Well, it's relatively easy in the application to lock out the system button, whether it's a slide in like it is in the Micro series or whether it's a dedicated key like it is on the XL series. And the last thing I wanted to point out, for those of you who are eagle-eyed, I mentioned that after the firmware update was complete and the unit reset, not after the clone restore, but after the firmware update, you notice that there were some errors that occurred immediately, one of which, of course, that I did point out was the fact that there was no program in it, so it came up with a configuration error. But one of the other errors that some of you may have noticed is there's also a battery error that will show up after a firmware update. And don't be concerned, that is just a normal thing that pops up after a firmware update. And one thing you'll notice is, or you probably did notice, is after I did the load clone, so the next boot up after the firmware update, everything was normal again. There was no battery error. So it's really kind of a false alarm more than anything else after you do a battery update. It has to do with the fact that the memory, which stores the fact that the battery was good on the last power down, was cleared as part of the firmware update. So it's not there for the next boot up, but then it's there for the rest of the subsequent boot ups. Okay, so hopefully that was some good information for you there. Now, this next demonstration that we're going to do almost certainly is something that most of you have never seen. And that is actually updating an Rcc product, which is our line of controllers that don't have a display. And those really are pretty unique in the way that they're updated firmware-wise, and I think a lot of you probably haven't seen that process before. So that's what we're going to demonstrate next, including a preview of a new utility that we're going to be providing that helps create a bootable disk. Now, why would you ever need a bootable disk? Well, you're going to need a bootable micro SD disk if you ever need to update the firmware on an Rcc. And so that's something that we're going to be releasing here soon, and I'm previewing it with this next demonstration. Now we're going to go ahead and do a firmware update of an Rcc. Now, as you can see, it does not have a local display, so the process is going to be a little bit different. Now with the XL4, I started out by performing a clone operation because I had an existing application. I wanted to get the machine back up and running in its exact state as soon as possible after finishing the firmware update. Now, there's no good way of doing a clone with an Rcc, but what we can do is make sure that we have a copy of the program that's running in it, which I have here. If we didn't have a copy, we could always do an upload. Now, there's also a way, if it's important in the application, and often it's not, but there's also a way to back up the register contents with the Rcc. And we're going to go ahead and do that before we start. And then after we're done with the firmware update, we can not only re-download the program, but we can also restore the actual register values. Okay, so let's go ahead and take care of that. We've already got a copy of the program here. Let's go ahead and go to Tools, and then Backup Register Contents. Okay, and instead of putting it in, let's just go ahead and put it in this location here. We'll just go ahead and use the default file name. Reg data dat, okay. Get register values. It's effectively going to back up all the registers. So whatever their current value are of all these registers, that's going to be stored in this file. Okay, so it takes a few seconds to finish this operation. And once it's complete, we'll have not only a copy of the program, which we had previously saved, but we'll also have a copy of all of the values of all the registers. Okay, so that is now complete. All right, so now we're ready for the next step. Okay, so the next step with the Rcc is that we have to create a bootable disk. And that's because that's the only way currently that you can do firmware updates with an Rcc is you need to create a bootable disk. Now, normally, to create this bootable disk, you would request from tech support a special utility that is based on a batch file that you would run, and then it would execute the process of creating a bootable disk with the firmware on it that you needed. Now, in this case, I'm going to show you a new utility that we're getting ready to launch, which will make it a lot easier to do that. It's not just a DOS batch file or a Windows batch file. It's actually a separate utility. So I'm going to go ahead and run it here. I'll right-click and hit Run as Administrator. It's going to ask me if I want this app to be able to make changes to our device. The answer is yes, because we're going to be formatting a drive. Okay, so here's what our OCS bootload creator looks like. All right, so effectively when it comes up, currently it's fixed to the latest version of firmware, and because this is a pre-release utility, it's showing a pre-release version of firmware. I'm going to go ahead and select, instead of an EXL10, I'm going to select the product that I have, which is an Rcc 972. I want the C-scan version of that. It really doesn't have a high-speed counter, so that's kind of irrelevant here. And then I'm going to make sure I select the right drive letter, and my micro SD card that's in a USB carrier is plugged in as drive E, and we definitely need to format the drive because remember, we're creating a bootable disk here. So I'm going to hit go. Okay, it's going to make sure that I want to format drive E, which I do. Okay, so it's giving me a status there. Okay, so there we have it. A preview of the new OCS bootload creator, which gives you the opportunity to create a bootable disk that can be used for firmware updates on an Rcc or as a recovery disk in case you have a firmware update, let's say on an XL4 or another similar controller that goes bad and you need to recover. Okay, now that we've got a bootable disk with all the right files on it, I've pulled it out of my computer. I'm going to pop it in the Rcc here on the side. Okay, now the way you initiate a firmware update on the Rcc is you take a sharp object like a paperclip, or in this case I've got a very thin screwdriver, and you press this recess push button, the one that says load. See if I can move my finger out of the way here. Disadvantage of being a lefty, I guess, right? But I've got the load push button here. I'm not pressing it yet. I'm going to go ahead and press it for 1, 2, 3 seconds, and you can see the LEDs starting to cycle. So that indicates that they are, or that the Rcc is performing a firmware update. So this process takes, 30 to 45 seconds, maybe a little bit longer than that. And when it's done, you'll notice a change in the LED status. There we go. So the normal result would be that the power light remains on, of course, but the run and OK light are off. Okay, so now that the firmware update is complete, we need to get the program loaded back in the unit again. And I'll go ahead and do that now by pressing download. And this is a tiny little program, so it's not going to take very long. Now, if you remember correctly, I backed up all the register values prior to doing the firmware update. And it's an optional step. You don't need to do that. But in some applications, it can be helpful to pick up exactly where you left off, not only from a program standpoint, but also from a variable standpoint. So I'm going to go ahead and go back to the Tools menu and select Restore Register Contents. Am I sure I want to do this? Yes, I do. Now I need to navigate to the folder which contains that backup file. Here I am, registerdata.dat. I'll select the file, select Open. Now it's starting the process of restoring all the register values into the controller that were there before the firmware update, or basically when I did my backup operation. So this whole process takes, in the case of this particular Rcc, it's probably going to take less than a minute to complete. And then the last step, once that is done completing, is we're going to go ahead and we're going to put the Rcc back into run mode. And then at that point, it'll be, fully updated with firmware, have the program put back in it, have the register values all restored to their previous values, and we'll be good to go. So I'll go ahead and press run. And away we go. Okay, so really just a couple things that I want to point out from that particular demo that I did. First of all, I bet a lot of you weren't aware of that whole backup register function and restore register function that's available in the Tools menu from Cscape. And, that's not just there for the Rcc, that's available for all products. And it's been there for probably 15 or 20 years. It's just I guess a function that a lot of people don't realize exists. Maybe we don't promote it that much, but yeah, it's there, and it can be very useful, especially when, for whatever reason, performing a clone operation is not practical, or something you can't do. For instance, like with an RCC. So I wanted to point that out to you as well. I also hope that you think that, or I feel like that the new utility for creating a bootable disk, that should be pretty useful. And I think you'll see more than just one or two reasons for that in another slide or two. But let's go ahead and continue on. Let's talk a little bit about these particular methods that we're using. First of all, Gary, got a comment from Gary Jordan. He said he's been using that feature for years. Outstanding, Gary. I think you deserve a medal for that. I don't know how many people I've shown that to that have basically said that, nope, didn't even know it was there. But anyway, one of the things I wanted to talk about next was, why are we using these methods that we've shown? The first method was connecting up a serial port or USB port. The next method was doing it through a micro SD card or in some cases a USB-A drive. Well, frankly, the main reason is because of security. With this scenario, the user has to have direct access to the unit to be able to update the firmware. So there's no real concern about some unauthorized person. Well, I'll put it this way. In order for an unauthorized person to update the firmware on the unit, they're going to have to get in the facility or get access to the unit to be able to do it. So that's really probably the primary reason why we continue to use these methods for doing firmware updates. But we're taking a look at additional options that we're going to offer customers, and I'll talk about those in a minute. The next thing I want to mention is what can happen potentially if you have a firmware update that goes wrong. I mean, it does happen sometimes, right? So, for instance, one thing that can go wrong with a firmware update via removable media is if you inadvertently press the update firmware button on the screen of the OCS instead of update bootloader button, it's conceivable that you could end up with a mismatch where you have a version of firmware that is not compatible with the version of the operating system that's already loaded in the unit. So you can get a mismatch there. If that's the scenario, then you can do what's called bricking the unit. And nobody wants to brick a unit, right? Well, the good news is you can recover from that. But the way you recover from that is by creating a boot disk, all right, using a utility like the one I just showed in the previous demo. As I mentioned, that utility isn't released yet. Currently, we have just a simple batch file that gets distributed as needed by the tech support team to help out those customers who are in dire straits with bricking a unit, for instance. Now, another thing that can happen for the units that are upgraded over the USB port or the serial port is you could potentially, let's say that you trip over the power cord during a firmware update and you power the unit down during the firmware update. And oh boy, now I've got a unit that isn't operational. Well, the good news is in that scenario, if your cable came out or your unit got powered down, you almost always can recover strictly by restarting the firmware update wizard and then manually selecting your model, an X4 C-scan or an XL4 C-scan or an XL7 can or maybe an EXL6 can open, whatever the unit is that you're updating. That my last example was lousy because the EXL6 is updated with the memory card. But you get my drift. If it's the unit that you're updating through a serial port or a traditional USB programming connection, then you can resume that firmware update or start it over again from scratch. You'll just have to specify using the update wizard what your particular product is that you're using. Okay, so those are all recoverable. All right, now let's talk about some planned enhancements to the whole process of doing firmware updates. The first one I've already showed you, right? And that is the firmware update utility, or the bootable disk creator, if you want to call it that. It's going to have several different functions. One function is that it's going to allow you to create boot disks, like we mentioned, which is required for the RCC and for recovering from an update gone bad. But it also could be used as another way of building a file set for an XL4 or an XL7 to update that just through the micro SD or the USB card. In that scenario, you just wouldn't select the format option, and it would gather the files you need and put them on the drive. Some other things that we're looking at for enhancements to our process, basically, we're looking at consolidating all of our firmware files into kind of one version. One thing you may have noticed when we show the status or even the, let's say the, well, let me show you here. When we go take a look at the a particular firmware version. So let me go ahead and go under X4 and let me take a look at the release notes for an X4, for instance. You've got multiple different versions that you're looking at. You've got a firmware and a BIOS and a CPLD in the case of a Micro X4. In the case of an XL4, you've got a similar scenario, but a little bit different. Let me show you that as well. Okay, I'll scroll down to XL4. Okay. Need to go in a little, sorry, I didn't scroll down quite far enough. Okay, let's take a look at the release notes for an XL4. Okay, it's similar here. Firmware, in this case, OS version and an INIT-RD. So you have these multiple versions to keep track of. You know, it could be simpler for users. So we're consolidating a lot of that into specific packages, if you will, that have one version number to make it easier for our customers to track. Now, one thing I will note about that, however, is that in the case of the FPGA and the CPLD, remember those are the files that are residing on the high-speed memory or the high-speed chip that's used for high-speed counting and high-speed outputs. Those will continue to be broken out separately. Okay, so you'll continue to see kind of a firmware package number, if you will, rev letter, if you will. And then separately from that, for those products that support high-speed counting, you'll see a CPLD version number or a FPGA version number, depending on the type of chip that that product has in it. Okay, so that's what I mean by kind of consolidating our version numbers, if you will. Okay, the third thing that we're looking at for enhancements is in some cases, you won't absolutely have to clear the application or erase the application as part of the firmware update process. We will designate in some cases updates which are benign enough, you know, from point A to point B, for instance, benign enough where a application erase is not necessary. Today, we always erase the application kind of as a safety measure, if you will. But there will be a point in the future where we don't automatically do that unless it's needed for a particular upgrade path. And then another thing we're looking at that's been requested by some of our OEM customers that have kind of far-flung enterprises with OCSs spread out all over the country and in different locations. But even though they're spread out all over the country, they have remote access from headquarters to all of their units, is we're going to roll out at some point in the future the ability for those types of customers to go ahead and do a remote firmware update, triggered by them, of course, and we'll come up with a process that's secure and also convenient for them, so they don't necessarily have to send a service person to the site in order to do a firmware update if that's what they want to do. If a new feature comes out that's critical to them and they want to add the support for that new feature, it'll give them an opportunity to deploy that change in a more efficient manner and a less expensive manner, obviously, than sending service folks, for instance. Okay, very good. So I believe that pretty much wraps up the material that I wanted to cover with you folks today. Let me bring Casey back in here. How we doing, Casey? So obviously you have seen that, Gary wasn't the only one who's seen that register backup tool. You obviously must have used that before, I would hope.
Yeah, absolutely. It's useful for a number of ways, even if you want to, you can change set points even with it if you really wanted to. But it's kind of a neat utility that's been there for a while, just like you mentioned.
Yep. The other thing that I know you didn't see yet was that the Bootloader utility that creates the bootable drive. That's something that even you hadn't seen yet. Is that true?
No, not quite. And I think it'd be really useful for sure. So I'd getting around the batch files that we use is a nice organizing feature to kind of get out there for sure.
Yeah, absolutely. And then it'll provide another alternative for folks to be able to build file sets for just regular old micro SD. It won't necessarily just be for booting. So, any questions or anything you think we need to answer? Or did we get everything taken care of during the show?
That's what I was looking at. I don't think we have any remaining questions. Just a couple comments from Waldemar and Gary saying that remote update would be definitely very beneficial and helpful. So that all sounds good, and looks like we're working on the right stuff in the right direction.
Absolutely. That's good. Good to hear. We always like to get feedback. That's another reason why we like to have these sessions, is to, again, provide another means for customers to feedback, suggestions to us, and for feature ideas, or, feedback on what we're working on, if it's the right things or the wrong things, that kind of thing. So,
good or bad.
You bet. Good or bad. That's right. That's why we want to do this. So next week, next Tuesday, we've got another session planned. I don't remember off the top of my head what it is. We'll get it posted probably within, maybe even by the end of the day, we'll have it posted on YouTube as to what the next session is. You can always check, I believe, on our website for the schedule as to what the topics are for the month of March. And we appreciate everybody for joining us today, and we'll wrap things up here. Look forward to seeing everybody next week.